Hey kids, so let me pose to you an interesting question. Death Valley is very low. In fact, it is 282 feet below sea level. And it has an average temperature of 91.4 degrees Fahrenheit. In contrast, however, Mount Everest is very high. In fact, it is 29,000 feet above sea level. But it has an average temperature of about negative 36 degrees Fahrenheit. So, if that's the case, if Mount Everest is taller and it is closer to the sun, then why is it so much colder?
So in actuality, the distance between the sun and the earth is huge. So if this is the sun, and this is the earth, the distance between the two is 93 million miles. So on a cosmic scale, ain't no mountain high enough.
But even so, this still doesn't explain it. Why is Mount Everest so much colder than Death Valley? Well, I'm so glad you asked. You see, the answer lies in pressure. Pressure and altitude directly correlate. Think of it as if you were in an ocean, okay? The deeper down you go, the more pressure you experience just pushing down on you. But why is this? It is because the deeper down you go, the more water is on top of you, pushing down on you. The same is true in Mount Everest. You see, the higher you go, the less air molecules there are pushing down on you. Thus, there is less pressure at the top of Mount Everest than at the bottom. But why does this matter? Well, this equation is why it matters. PV equals nRT. What does this equation mean? Well, this equation relates pressure to temperature, as you can see by P and T, which represent pressure and temperature correspondingly. Now, if we assume that at both the lower and higher elevations that V, N, and R remain the same relatively, which they do, then we can see that P correlates to T.
Pressure can be thought of as tiny gas molecules moving rapidly and colliding with each other. Higher pressure means that there is more collisions and more energy of movement, also known as kinetic energy. Temperature is the measure of this kinetic energy, and so when there is more kinetic energy, which means more collisions and more particles moving and colliding with each other, there is higher pressure. Thus, when there is lower pressure, there is less energy in the movement of the gas molecules, so there is lower temperature.
Here's something that might surprise you. The sun doesn't heat the air, it heats the earth you're standing on. And typically at lower elevations, the ground is more expansive and flatter. At higher elevations near mountaintops, the surface area you're standing on is smaller since the land is much more jagged. At lower elevations, you are closer to the ground you're standing on, and since heat radiation spreads out as you are distant from a source of heat, you will experience a higher temperature.